to the right here. Okay. So I know that I have 1, 2, and 3 as my, side lengths. And remember that 3 is actually a root 3. And I know that 30 degrees is next to my 3. That leaves that 60 has to be here, and obviously the right angle side is there. So sine 30 is opposite, which is 1 over 2. So this is just 1 over 2. So 1 over 2 times 1 over 2, or 1 over 2 squared. So that's that square there. So you have a fraction on the top. Now we have 1 minus, what's cos 30? Cos 30 is adjacent, which is root 3 over 2. So here we have a fraction in the numerator and a fraction in the denominator. What I like to do is kind of split this fraction up into two separate parts and try to figure out the numerator and the denominator separately. So here I have the numerator. And the numerator is just 1 over 2 times 1 over 2. That's just 1 over 4. This is my numerator. My denominator now is 1 minus root 3 over 2. So how do I simplify this? Well, I know that 1 is 1 over 1. And I know that I need a common denominator to add or subtract fractions. So I'm going to multiply both the top and bottom by 2. So this becomes 2 over 2 minus root 3 over 2, which is obviously 2 minus root 3 all over 2. So now this is my denominator. This is my numerator. What I do is I bring them together now by doing 1 over 4 divided by 2 minus root 3 over 2. And instead of writing them in fraction form, see this, instead of writing this fraction line, I wrote the division sign, because that fraction line means division, in case you forgot. So numerator divided by denominator. And since we're just dividing fractions, we should know that, hey, dividing fractions is pretty easy. Dividing fractions just becomes multiplying fractions. If I flip the second fraction. So now I have 1 times 2, which is 2 over 4 times 2. But wait, before I do that, I know that I can simplify fractions if there's common factors. So I know that this can become a 1 and this can become a 2, because I can factor out the 2 from both the 4 and the 2. So this really becomes 1 times 1 over 2 times 2 minus root 3, which is just 4 minus 2 root 3. And some people like to keep it in factored form, so you can just write 2. Both are equivalent answers. I would give you full marks for both answers here. So when I multiply it out, it's 1 over 4 minus 2 root 3, or 1 over 2 brackets 2 minus root 3. So that's the final answer, and you can see that they have both actually answers as well. As you can see, they're both the same. It doesn't make a difference. Okay, we are going to move on. I will be moving on to this lesson here. Okay, this is a lot of talking now. Oof. All right, everyone. We will be learning now how to draw angles on our Cartesian plane, or a grid, or an XY coordinate. So let's start. First things first, let's draw our nice little XY grid. I'm just gonna, instead of drawing every single line, I'm just gonna draw the main X and Y. All right. So an angle, from my understanding, is a definition between two lines, right? Like you need two lines to be able to get an angle. You can't get an angle from one line. I guess you can technically. If you have, from like that, I guess. But yeah, why did I say that? Well, there's the definition of an angle when it comes to, our grid. Our starting point is always going to be our x-axis. So this is our starting point. Our angle starts like this. And then it rotates in this direction here, which, if you know the way a clock goes, it's counterclockwise. So this is the standard way that we calculate angles when we're drawing angles. So here we have an angle of, let's say, 1 degree, 2, 3, 4, 5, 10, 15, 20, 30, 50, 60, 70, 80, 90 degrees. So our quadrant 1, our first key point is here, and that is 90 degrees here, which makes sense. So 0 degrees is our starting point, and we're going, here to here, and then we're obviously increasing the angle. And when we get to here, we're at 90 degrees. Now we're obviously going higher, so 91, 92, 100, 105, 110, 130, 150, and so on, until you get to this point here. And this point now, if you know, what's a straight line? How many degrees is a straight line? If you haven't figured it out, it's 180 degrees. So this point is 180 degrees. All right, so that's 90, that's 180, and then you keep going 190, 200, 220, 230, 240, 250, 260. And if you haven't figured this out, each quadrant is going up by 90 degrees, which makes sense because it's, 90 degrees. That makes sense. So this is going to be 270 degrees. And then the final one, we write it as 360 degrees. Why? Because 360 degrees is a full circle, and a full circle is 360 degrees. So now we've gone a full circle. So that is how you draw your angle when it comes to, an XY grid. There's some labels that you need to know now. The first labels I'm going to label are quadrants. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. This is just how we have labeled them in math. So quadrant 1 is a quadrant where you have angles between 0 and 90 degrees. Quadrant 2 is between 90 and 180 degrees. Quadrant 3 is from 180 to 270. And 270 to 360 is quadrant 4. Pretty straightforward. So each quadrant, 1, 2, 3, 4, make sure you know how to label them. That's important. You need to know these definitions. So there's something called an initial arm. An initial arm is always on the positive x-axis at 0 degrees. It doesn't move. So your initial arm, well, I probably should have picked a different color. So this is your initial arm. That doesn't move. What moves is your terminal arm. That's the arm that kind of rotates along, the angle, I guess. And your angle that we are calculating is always called the principal angle. And this angle is always from your terminal arm to your initial arm. So remember, your initial arm is just always right here. It's just chilling. It doesn't move. It's just a reference point. It's just to show that the angle is from the terminal arm to the initial arm. So let's say my terminal arm is in quadrant 2. So if my terminal arm is in quadrant 2, that means my principal angle, the angle that I'm calculating, is going to be from here to here. So it's an angle that's obviously bigger than 90 degrees because it's past the 90-degree point, but it's obviously less than 180 because it's not yet 180. So whatever the angle is, I don't know, 120 degrees, whatever. We're going to figure out how to calculate it exactly in a moment. But that is your principal angle, and that is denoted by the variable or symbol theta. So theta is your principal angle. So that is between the initial arm and terminal arm, and its value is between 0 and 360 degrees. Now, one of the more important ones is something called the related acute angle. Sorry, not really more important, but more challenging for students to understand. I don't know why, though. Your related acute angle is the angle, listen carefully, from the x-axis to your terminal arm. And what I mean by x-axis, well, I mean the nearest x-axis. So from here to here is your related acute angle, and it's called beta. So this angle from here to here is beta. Now, beta changes